My name is John Rodriguez. I'm a senior staff engineer at Duolingo, and in this talk, I'm going to be discussing what APIs we're seeking to offer in the 2.0 release of Paparazzi, as well as highlighting the changes made, or some changes made, since last droidcon NYC just 9 months earlier. Okay, let's start off with talking about separating concerns. Today, Paparazzi still operates as it did from the very beginning, as a JUnit 4 test rule. Some people have asked, what about JUnit 5? While it might be a hot take that JUnit 5 is not probably worth adopting as your testing platform, there really shouldn't be anything that prevents you from enabling screenshot testing for that or any other platform. So one of the paths that we're taking is to separate that core snapshotter functionality into its own SDK. Its responsibility will be to load layoutlib, which is the rendering engine that drives composed previews in the IDE, as well as all the direct and transitive resources that are associated with the module that you're working in, along with rendering the viewer composable you're passing it. Now, these operations are very I/O intensive, and so we'll provide setup and teardown methods, giving it a lifecycle. We're also looking to create an abstraction for the result of that snapshot operation. We know that we're getting a ping or an animated ping in the case of a video, but referring to it as a buffered image or a buffered sync is a slight leaky abstraction. Encapsulating this as a snapshot or a clip will also allow the potential to pass arbitrary data down the pipeline. Now, I mentioned layoutlib, and for those unfamiliar, that's the heart of what makes Paparazzi possible. We use the same binary artifact that Android Studio uses to render layouts or composable previews, which creates a consistent rendering experience whether you're working in the IDE or running your CLI command locally or on CI. This also sometimes means we find an upstream bug fixes improving the ecosystem. Yay, open source. That's the very reason why we do it. However, some people have asked whether we would support RoboElectric native graphics. Recently, RoboElectric provided its own way to run the Android rendering engine. Also, what if someday we want to support iOS screenshots taken on a headless simulator and make Paparazzi fully KMP? Part of the way to get there would be to not necessarily have such a hard coupling to layoutlib, but abstracting the concept of a rendering engine would be that first step. Finally, operations like record and verify are really wired to the test task via the Gradle plugin as a system property. Now, it was designed this way to some extent to decouple the Gradle plugin from the test rule, allowing for other potential build plugins. When Paparazzi came out, there were several talks at droidcon talking about how maybe Gradle should be abandoned on Android platforms in favor of something like Bazel. And so, kind of hedging our bets, we were like, okay, we really going to make a Gradle plugin, because at the time when I was at Cash App, we used Gradle, but we know that people at Uber were looking to use Paparazzi, and they have a variety of build systems, and so that was part of the design. However, that system property finagling of making operations wired the way they are makes it challenging to have custom snapshot handling. I apologize for the feedback if everyone's hearing that as well. So right now we provide by default record and verify, but maybe you want to do something boutique. And right now that's just difficult. It's not impossible, but you have to really kind of get in the weeds. So here's a rough spike of the end goal. The idea is to break this all down into its modular components, allowing for both more customized test runs and extending Paparazzi's use cases beyond testing as a visual snapshot library. This code is intentionally not in a method body to highlight how it should be roughly transferable from a CLI command, say in clicked, to say a JUnit test rule or a JUnit 5 test extension. As a sidebar, if you're interested in participating in any of the areas that I mentioned today, we have a 2.0 design doc that we're working on in the open. And I'll also be posting these slides after the talk, so you don't have to scan or take photos in the meantime. All right, so now that we've had our palette cleanser, our amuse-bouche, if you will, of what the initial external APIs might look like, let's move on and really start talking about image diffing. From the very start, Paparazzi has relied on the concept of pixel perfection during image verification. What you see is what you get. Every pixel's RGB value in the expected golden image should correlate to that of the actual image that was just rendered from your UI hierarchy. Surprisingly, this is held up for most of Paparazzi's timeline. Not really. We actually provided a threshold which said that basically, if some small percentage of pixels are not pixel perfect, let's just forget about it. And that would work around some of the occasional aberrations. We'll touch on that more in a bit. But often you would bump Paparazzi or Layout Lib, and all of a sudden the status bar, the navigation bar, would have these 5 or 7 phantom pixels that would just fail your test for no reason. And in fact, until you use image magic or a differ to really kind of zoom in and see what's going on, you're scratching your head because there's literally no perceptible way to tell the difference between the two snapshots. That's annoying. For a while, we swept it under the rug with this percent difference. One thing to know is that in the early days, Layout Lib was not packaged as a Maven artifact. And so on Cash App, we basically pulled the jar from the Android open source project and repackaged it, publishing it to Maven Central ourselves. I filed an issue about, I don't want to say 3-4 years ago. And finally, Google decided to ship its own version of Layout Lib, which we know because now they have their own screenshot plugin as well. This is really awesome. So now we don't have to do that silly Gradle with script magic. So about a month ago, Paparazzi stopped publishing its own Layout Lib and used Google's. Why do I mention this? Well, very soon after, we started to get even more issues around rendering difference. Rendering differences in particular between the platform-specific builds on Layout Lib. And so that is to say, if you recorded your snapshot on, say, Windows or Mac OS, checked it into source control, and then verified it going forward on CI, that CI probably ran on Ubuntu or some Linux flavor for cost reasons. And so while the layout graphics core are very similar on either platform, when it comes to things like gradients and dithering, or things like text anti-aliasing, you'll see that this isn't usually the case. Layout Lib will delegate to the underlying operating system's native graphics toolkits. And for example, on Mac OS, there is no way to disable anti-aliasing even if you try post Mac OS 14. However, while debugging the issue, I noticed a very strange correlation in the case where pixel RGB values differed, but never differed by more than 2. And so thus was born the off by 2 pixel differ, which is the workaround that we have in Paparazzi today. And now we know this is not a great solution. It gave us more time to actually do more research and understand, to a certain extent, understand that the search for absolute pixel perfection is simply not possible due to these differences. Talking with some of the people who work on the graphics tool team on the Android team at Google, I basically came around to the fact that what I was searching for is just not possible. This has led some people to opine that the true solution is just to always record on the same operating system altogether and circumvent the problem. This means basically don't record locally and instead record on your CI and then use a web-driven approval mechanism to sanely choose which golden images you want to become the source of truth. However, the real question is we want to answer here is there a way to simply do a reasonable fuzzy match between these artifacts with some reasonable sense of confidence? Maybe we don't need to be pixel perfect, but we should be close to perfect. And do we really need to introduce now a whole aberrant workflow where you have to work on a CI/server-driven interface, removing your feedback loop from your local environment where you can get quick feedback to something that's a little more drawn out? To each their own, but for the meanwhile, we still think that there are a few approaches that we can try to answer that question. One algorithm that we've been looking to for image diffing is called mean structural similarity index. If you've heard of it before, that's great. Not surprisingly, it's what Android's screenshot plugin is using. There's a lot of math. We're not going to go through all it, but some of the things, if you broke out your AP calculus books, this equation basically says that given a certain pixel, you want to calculate the luminance, that is the intensity of light that's emanating from that pixel, the RGB values to a sense, calculate the variance of that luminance across a certain area, and then the structure. We'll talk about more of that in a second. And so here's a canonical image. We're going to divide that into, this is not at scale, but let's pretend those are 10 by 10 pixel windows. And then for each window, we're going to compute the intensity of that perceived luminance, meaning that not each of the RGB components are going to be equally weighted. Some color perceptions, some colors are, what am I trying to say? Some colors are visually more important than others, let's say. And calculate that luminance for each pixel in that window. Those intensities will then be used to calculate the means, the variance, and covariance of the window as denoted by those Greek letters. And so the idea is that in that window, you're calculating this luminance, and then in turn, all the windows are going to be fed back into that SSIM equation, accumulating the values and returning the mean for all the valid windows in that image. At the end of the day, you're just trying to figure out, are these two images structurally similar? Structure being, here we see a circle, and yes, maybe there'll be some fuzzy aberrant pixels, but does it still kind of look like a circle with the gradient that we're expecting, and we can minus like the few pixels that are not. And so as a recap, that was a very quick recap. There's a paper that you can read if you really love the math, is that this is a perceptual metric that compares images not on pixel perfection, but on those concepts of luminance, contrast, and structures. If you have a button with a sharp border on a light background, you would expect any deviation to that to be flagged as incorrect. But if you have dithering from a gradient inside of a circle, maybe not so much. It really will depend. And this basically mimics how we perceive color as humans. And so it detects visual degradation, but does not apply an overly sensitive approach, meaning that minor pixel noise that was kind of annoying us with the pixel perfection goes away. And it also outperforms for things, as I just mentioned, the gradients and anti-aliasing. And so the idea is that if you're 1 or above, you actually can in circumstances be above 1. Not really sure what that means, but whatever. Clamped to 1, you're a perfect match like before. If you're 98 from an SSIM, you're similar but virtually identical. And then anything below that is where you should start to dig in deeper. And so this was one of the sample images that was failing in that previous issue I mentioned. And so when you're applying the pixel perfect algorithm, it failed obviously because there were 40, can't you see them? 40 different pixels differences between the two. And then off by 2, this test would have passed simply because we just called them similar pixels instead of different pixels, and we kind of just shoved it under the rug. But using SSIM, it only detects this as being 1 pixel, and that's underneath that 98% threshold, so you will pass. Now that was an example of a widget image difference. Let's look at a full screen one because, right, higher resolutions, more content, more potential to hit these error conditions. And so Pixel Perfect would see 44 different, again, most of the erroneous pixels will occur where that gradient inside the circle lives. And so here it's, wow, all right, an extra 4 pixels. Same thing with off by 2. Instead of calling them different, we'll call them similar. But MSSIM still considers only 1 different pixel. And so right off the bat, we can see that we're getting a lot better metric. And so SSIM is showing to be promising, but we're not stopping there. We want to see how much we can really kind of trial and error across different differs. So I won't be going into the math on the rest of these, but I'll just talk of them on a high level. The foveated image difference metric, also known as FLIP, is an algorithm that was devised by NVIDIA for realistic rendering validation. And it attempts to perceive images how the human eye will also perceive them. It sounds like SSIM, but instead of structurally comparing similarity, it's going to take a high focus on the center of the image and blurriness at the edges. Again, trying to mimic how the human eye would perceive things. That being said, this is susceptible to things then like dithering or anti-aliasing. So while we're going to try it, I don't have high hopes for the success of that. There's another one called Scaled Invariant Feature Transform, or SIFT. This is more used for object detection, and so maybe will be helpful when you use video snapshots, not static snapshots, because it'll be able to match key points. And so if you have a spinner that is rotated 45 degrees between successive snapshots, it would actually be able to tell that that's still an identical image. It would be able to ignore device densities and rotations, which you may not necessarily want, because if you skipped a frame in your snapshot, in a static snapshot, that could actually be an error. But for a video, maybe that might be helpful. We don't know. We just wanted to try it out and see what data we can get. And then finally, a third algorithm we're looking into is called the perceptible delta E. I believe Michael Bailey filed an issue suggesting this from, I an analogous tool that iOS developers use. And so we dug into it. And so this algorithm has had several iterations, the most latest in the year 2000. It uses a uniform color space. Right now, we're used to using GB. Yeah, sorry. But there's a perceptibly uniform color space called CLab that does a better model of how human vision works. And so it's really strong at color mismatch detection, but again, might be overreacting to things like anti-aliasing. And so we're not entirely sure how this will play out, but we're going to try it. The idea with Delta E is that RGB is going to tell you what your screen, what color to show, whereas CLab is going to tell your brain what color it saw. And so it's different from the perception level. Again, if you really want to nerd out like I have, look at some of these things, throw into ChatGPT, see what it spits out. But now let's talk about measurements. Right now, MSSIM has been pretty performant compared to Pixel Perfect and Off by 2. And the fact that it's seemingly more correct is promising. I will say don't get too distressed by Flip, Sift, and DE 2000's terrible numbers. In preparation for this talk, I pretty much measured a very quick output from the GPT-4o model. So I will probably have to revisit this and prompt this some more to obtain better metrics, but TLDR is we're working on it and there's positive results to be found. And so the way that this will land in Paparazzi is like something like this. You'll set a Gradle property. We're unclear yet whether we want to expose the differ interface so that you could supply your own differ, because at that point then it may be difficult to control what issues will get filed and how we react to them if you're basically doing your own way of image comparison. But we're not closed off to the idea. But this is how we're going to start for now. Okay, let's pivot away from image diffing and talk about accessibility. We had a few improvements to our accessibility framework. And so in case you missed it, Paparazzi offers accessibility renderings to help you ensure that your app or library is WCAG compatible. That's a web standard for accessibility that has recently caught fire on mobile apps because until recently, we haven't been really good at making our mobile apps accessible, and we should do a better job. Recently, Colin Marsh from the Cache team added this new page to the repo explaining how to get started and what things you might want to look at first if you are considering ensuring that your app is more accessible compliant. And you can check that out here. One thing to know, however, is that we're going to deprecate the validate accessibility portion. So we'll still have accessibility screenshot tests, but the validation is what we're deprecating here. The idea is that the deprecation of this, it wasn't really providing a lot of value, and we were just surfacing Layout Lib's logs of like high contrast, and we feel that the library is really best focused on the visual accessibility problems that surfaced in a way that we'll show just in a second. And so this will also help reduce some maintenance burden going forward as we modularize towards that goal that I started the talk with. And if you were using these features and you'll miss them, that's okay. Android Studio is still supporting them well via the Compose UI checks, again, because it too is using the very engine Layout Lib that Paparazzi currently uses. Now, the way that the accessibility feature works today is via the render extension, that API that Paparazzi provides. And so from there, the accessibility render extension does some analysis and sets up a main to detail layout, annotating your elements with visual feedback regarding their accessibility compliance. And that looks something like this today. However, one gotcha is because we're manipulating that UI hierarchy to add that legend, we only support accessibility feedback for full screen UI. And so if you wanted to take accessibility screenshots to your widgets, they just don't work. And because they don't work, for the moment, we currently disallow them. That's not great. One of the things that we're looking at is actually proposing to get rid of the render extension altogether and replacing it with in tandem, one part interceptor. So if you're very familiar with OKHTP interceptors, we want to basically have a pipelined approach to what Paparazzi can do post Snapshot. So one part of that would be the interceptor, and another part of it would be the reporting feature. This master detail, this is actually, given the left pane's view hierarchy, we're going to attach you to a parent view group that also just renders the right side. So this is really just one big Android view. And my point is it shouldn't be, because to do that, we have to actually bring in compose, class path, or other artifacts to do that. This could just be a JSoup HTML report. And so that's probably what we're going to try to do in order to get some of that flexibility back. The interceptor, mind you, could still modify the current view hierarchy. It just won't append to its parent. And so you'll still get the visual part that you saw on the left pane. But also, we've seen a cool use case where you can do redacted fields in another form of reporting. And so being able to modify the current view hierarchy is still precious. It's just all the cruft around it that we'd really like to move away from. Let's talk about some new things in the Gradle plugin. So one small thing, it's small but important, is that we're no longer forcing your Kotlin compile version or your Android Gradle plugin version to be whatever Paparazzi is. We want you to adopt Paparazzi versions more frequently to give us feedback in the 2.0 alphas. But it would be really annoying if in the process, if you were behind, not that you should, but if you were in your Gradle bumps or your AGP bumps or your Kotlin bumps, that now you can't test Paparazzi. So we have completely decoupled that. We probably should have done it for a while, sorry. But now we hope that your homework is to go out and please adopt these 2.0 alphas sooner so that we can get feedback while we're in the alpha phase. Again, remember, once we're final, it's a little harder to change those APIs. So get in there now. And maybe one other carrot on stick is we've just landed API 36 support in the Alpha 2, with Alpha 3 scheduled to go out. I believe I just updated the milestone last night, I think July 15th. Another nice to have is we started showing those failure diffs in the test report. Previously, if you had a failure diff, either you had to finagle CI to surface it through whatever its UI was, or you had to dig in your build directory and kind of search for that. And again, neither was great. So if you're used to looking at JUnit test reports, why not just have it there? So in case you missed it, it's that little toggle. The images can be rather large, which is why we collapse by default. One unfortunate part is to implement that, we had to copy a lot of the internal Gradle HTML report rendering code to accomplish that, and hook in a custom test reporter. And really this is just, and we use the package private API, and back to programmer jail we go. But not surprisingly, sooner after this landed, Gradle submitted a PR to eliminate that internal hook. This is why you shouldn't use internal APIs, I know. But there was really no other way. Like if you've tried to do your own JUnit test reporting, it's not very configurable. So if you follow how the Android Screenshot plugin does it, they actually create currently anyway, they create their own pipeline of doing JUnit reporting so that they control the XML generation, the reporting and everything, which that's like, cool, that's very much on the other extreme. I just want hooks to be able to hook in metadata. And so, yeah, this is going away, but the reason is that as of Gradle 8.3, Gradle now offers test authors a way to hook in their custom metadata into the HTML report. Now, this does come with a bit of boilerplate. Test authors now need to write their own test task. They have to deal with test filters differently. If you really love running tests with -- tests, this wouldn't work with that. And so that's not great either. So I've reached out to Gradle to hopefully come out with an alternative for maybe simpler hooks where we just want to pass an image. Can we just put an image in the report and call it a day? Moving on, one other thing that hasn't gotten much love since the very nascent days of Paparazzi is something that we dubbed development mode. It doesn't look great, and that's why it probably hasn't gotten much love. But the idea is that we were going to keep track of your snapshots as you happily develop your feature, allowing you to not only verify progress, but also at what point potential regressions might have been introduced. But composed previews are really good. It's a table stakes feature in every engineer's development cycle. And so the feedback loop is just faster and better in the IDE. So we're going to get rid of the developer mode, which will also allow us a little more flexibility in some of those refactor goals, because things like how we name the tests are a bit of a factor. However, I'm proposing a new feature in its place that I just spiked out this week. So right now, you can only apply the plugin to an app or a library module. But what happens if we could apply the plugin at the root project and expose a Gradle task with a capability that'll allow you to aggregate and view all your snapshots and videos in one place? We currently, in each module, while generating the snapshot, already generate some metadata that previously fed that hokey development mode I just outlined. We could repurpose and reuse that and just propagate that via an aggregating task in the root project. If you're familiar with Tony Robilik's dependency analysis plugin, it works in a very similar fashion. It does reports on a very or even the JUnit aggregation module, generate granular feature-specific metadata, propagated up to the root so that you can get a bird's eye view of your entire project. And so um, the finagles of how this works is really in the weeds of Gradle. It's called variant sharing artifacts. If you want to really kind of nerd on that, I gave a talk last year on it. I will spare you the details here. But this is the end goal. We now in Paparazzi in Alpha 3 will be introducing a very limited snapshot browser. The idea is that you can provide tags either on the test rule level, the class level, or globally. And yeah. And so the idea for now, because we don't have much in the sample, which that's another homework assignment, we should probably make a more robust sample, is that right now, if you wanted to kind of just hone in on all the landscape pictures, you just either select the appropriate drop-down menu element or click on the chip on top and filter down your screen to that. And if you click on one of the snapshots, you get maybe a little more surfaceable information. And so this might be great for feature teams that are really trying to establish ownership of certain modules, and also working with designers that really don't want to see all the app snapshots at once, really want to hone in on a particular feature set for a particular sprint effort. Some other potential ideas is maybe bringing back some of that snapshot idea across app versions. Right now, Paparazzi just cares about the current state, but we also have Git, and we're using Git LFS, but we could also do something to still keep some timeline. Maybe allow some limited theming through the DSLs. That was a very austere browser. We could do better, and everyone may want to kind of hook into their corporate portals and host it even internally. And then also, again, if we do host iOS screenshots, we want to enable a plugin for that. And it'd be really cool if we can have something like an AI agent that could analyze and finally search for feature parity across Android and iOS using the screenshots. If you have any other ideas, please propose them on that discussion board I shared earlier, and will be in the slides. Another thing that we're looking at is proposing a new keyframes API. This is in particular for the video. We call it GIF. We're probably going to rename that to clip or something similar. But the idea is that in a video, there are times where you still want to interact with the UI, do a button clip, do a swipe. And so the ability to kind of inject keyframe injection sites to set state on the underlying view would be really handy. And so, yeah, that's something we're exploring. Kudos to Jesse Wilson for proposing that. And then another thing that Saket Narayan on the Cash App team is working on is the idea of fake system UI. So right now, LayoutLib doesn't really do a good job of dispatching window insets to the view hierarchy. And so there are just cases where it doesn't work. And individuals, consumers of Paparazzi have found workarounds, but it's a lot nicer to just supply it as a first-class feature. So like I said, Socket is working on an idea that will not only just render a custom keyboard or navigation bar, but also will dispatch those insets accurately so that you can verify that your UIs react appropriately. The first one, actually, this is the static image. If you're curious to know how to do this, definitely ping Socket. I don't think he was able to make it to the conference, but I'm hoping that he's either gonna upstream this to Paparazzi or maybe have like a separate project where this is reusable and Paparazzi will simply incorporate this. And so I don't know if this is a demo, but yeah, this is literally using this tool that he made where it's able to record scrolls and touches. And other ideas that we were thinking about is basically being able to do view transitions. It's like, what if, just what if, Paparazzi could replace Espresso? Let's just leave it at that. Please follow us in the repo. That's pretty much the end of my talk. I'll take any questions you have right now. Thanks. I think if you have questions, they want you to line up at the mic in the center. No pressure.
Can you hear me?
Now I can.
Can you hear me? Cool.
Yeah.
So the solve with LayoutLib being that you didn't have to publish it anymore, that was kind of like a big hurdle. I assume it's a big win for you guys. Is there anything else that's sort of looming over your head that you wish was solved, maybe by Google or Gradle, that is still kind of unsolved, that would like enable some more things you can't do today?
Oh, sure. Yeah, that's quite a bit. I think the diffing, or at least exposing some of those things, would be great. Like, there are many by now, many alternatives to Paparazzi. I have my reasons for still vouching for using Paparazzi, but there's still a lot of common core components to doing. You need to still take a snapshot. You still need to do verification. And I think Google could maybe expose some of those things. For example, the resource repository, the way that Paparazzi knows how to reference your r.string whatever in your APK when you're in a compiled app or on the file system via the IDE. There is a module in the Android open source project that shows how they do that, but we basically copy it over because it's not modularized. And so Layout Lib was a really great step forward, but I think they could probably publish 3 or 4 components to make that even easier, at least on my side. I don't know about anyone else's. On the Gradle side, I think that test reporting, although they have been I won't complain, they've been really receptive to some of the comments. I've been commenting on their PRs. It'd be nice to get to a point where maybe we could get there earlier, because basically I'm commenting on drafted PRs, and that's no fun. Someone's already put in the work and they thought that they landed, and here I come along saying, I wish this was simpler. So yeah, that'd probably be my top of mind wins. Yeah.
Thanks.
You're welcome.
Oh, yeah. When I evaluated Paparazzi a while back, there was an issue with if we were trying to run the same test on multiple devices, like if we wanted to have the same test on 2 different types of phones, 2 different then 2 tablets or something like that. Is that easier to do now, or has that been addressed?
It's never been supported to run on device. That's probably the thing you're hitting.
Sorry, I shouldn't have said devices. I guess targeting like a test that has a snapshot of a phone-sized thing and a tablet-sized thing.
Oh, I see. Yes. So yeah, there's something in Paparazzi called a device config that represents the form factor and a bunch of other things. It's just basically how dense are your pixels and how big is your image. What in particular though was the issue that you're facing? You were trying to go from tablet to phone and that wasn't working? Because it sounds like it might be the rendering differences that I outlined, which is exactly what we're proposing to solve. Yeah, I wish I had a better answer, but I feel like I would need to suss out a little more what the problems were. Yep, but I think it's fixed. I think more people have been starting to use it. Yep.
You mentioned supporting potentially Kotlin multi-platform and I assume Compose multi-platform. Is that on the roadmap? I assume that's not on the roadmap for 2.0, but at some point in the future.
You're right. So the reason I mentioned that was really when talking about the engine component. So right now the engine is Layout Lib hard-coded, but we really are interested in seeing, for example, that it's not a voting contest, but some people moved away from Paparazzi to say Roborazzi because of the fact that it made Robo-Electric native graphics a first-class win. So we're like, all right, if that's the only differentiator, let's try it out and allow people to hook it in. But really the point there is, all right, if you expose that engine interface, now you can really kind of hook in anything. And so making Paparazzi Compose multi-platform by design isn't a goal per se, because I don't know what you would do when right now the only thing you can render is our Android targeted things. But if we already have that engine and we see there is a potential to run that headless simulator or a way to get an iOS snapshot, then yeah, we're open to it. It's a maybe, and I don't know if it'll ship in 2.0 to directly answer that question. If it did, it'd probably be right before cut if we were looking to see if we can do a little research in that area, but probably fast follow.
One of the challenges that we were working on was changing the directory location for the gold images. Is that going to become something standard in Paparazzi 2?
Yeah, that's a good call out. I forgot to mention that. The short answer is yes. Right now, you are kind of not required, but we are trying to promote that your snapshots would live alongside your source. Some people don't really like that for whatever reason. So yeah, we're probably gonna just allow that. I think the trick there is the Gradle plugin does path correlations, and so we've been bitten a lot by doing absolute paths, which is a no-no in Gradle, right? You need to be all relative. I think it's also not plane friendly with things that are outside the project subtree. I'll need to confirm, but I think that's one of the things. But if aside from that, it's like, yeah, it's just pass in whatever path you want and store wherever. Yeah.
Yeah, that'd be ideal. I mean, just a little elaborate on it. We struggle just because we don't have get LFS access, and so when you don't have that in a large repo, thousands of images, you can imagine what happens.
Yeah,
So
understood. You just want to slap it in an NFS share, S3 bucket, whatever.
Exactly. Thank you.
Yep. Cool. I think that's it. Thank you.